Okay, so is my presentation visible to everyone?
Yes, sir, visible.
Okay, good. So still we are in the first unit, that is introduction to the electric vehicles, and class number 4th, 3rd June 2025. So in the previous class we discussed the following four topics. So that is the first one, that is a traction power and vehicle motion. Then we discussed type of electric vehicles. So we have a total four types of electric vehicles. Then we discussed the drive cycle. So what about what is a drive cycle and why we are using, what is the purpose and how we can decide the drive cycle and everything. So this topic we already discussed in the previous class, and as well as the energy flow in the electric vehicle. So we can say starting from the battery to the vehicle wheels. So how power is flow from the battery to the transmission shaft. Okay, through the motor, controller, and everything. So is there any confusion, any query? You want to repeat that topic? Otherwise, you want to discuss in this class? Is there any topic, any confusion? Okay, if no confusion, no any query, then we can continue with today's class. So lecture outcome from the today's class. So we can start with the first topic, that is calculate the mechanical power with and without gear. So suppose we have a gear, then how we can calculate the mechanical power, and suppose we don't have a gear, then how we can calculate the mechanical power, and what is the purpose of the mechanical gear, correct? Impact, second topic, there is a impact and benefits of the EV on the utility grid, and that one is the last topic for the first unit. So today we will complete the first unit. Then we will see the numerical of the EV. So like basic numerical of the EV, so they'll calculate the rolling register, dynamic force, and some more parameters. So we will calculate in this numerical section, correct? So today we have only two topic, but that is a lengthy topic. So gear system. So introduction to the gear system in the vehicle. So I hope all you drive the like vehicles. So that is like maybe the petrol vehicle, maybe the diesel vehicle, yeah, maybe the some student, maybe the electric vehicles. So and gear is a fundamental component in the IC engine, that we can say the internal combustion engine, but sometimes we use in the electric vehicles also, but only 10% chances. 90% chances we are not using the gear system. And suppose we are using the gear system, then that is only single power transmission gear system. Okay. So what is a gear? So gear system is essential component in vehicle used to transmit the mechanical power from the engine or motor to the wheel. So basic role of the gear, so we have to transmit the mechanical power from engine, otherwise the motor. In the case of the IC vehicle, then we can say the engine. In the case of the electric vehicle, we can say the motor. So from engine, otherwise the motor, we have to transfer the mechanical power to the wheel. So wheel can rotate, correct? So it enables the vehicle to operate the efficiently under the various driving conditions such as acceleration, climbing, cruising condition, and braking. So acceleration means we have to accelerate, correct? Climbing, so we can climb on the hill. So that like Nepal area is totally hilly area, so we have to climb down, climb up. Cruising condition means suppose you are driving on the highway, same speed, maybe the 80 kilometer per hours, you can drive, correct, at constant speed, then we can say the cruising and braking operation, correct. So these four modes we can drive our vehicle, correct. So that time it is required for the gear system. Purpose of the gear system to adjust the torque and speed. Yes, whenever we can say the vehicle, maybe the ICE vehicle, maybe the EV, so we have to control only torque and speed, correct? To adjust torque and speed between the power source, that is the engine, otherwise the motor, and the wheel. Okay, so how much power is required to the wheel, so that we can control by the gear system to make the engine or motor characteristic to the load condition. Maybe the load is a dynamic, maybe the steady state condition, maybe the sometime load is a, maybe the 25 newton meter, maybe sometime is a, maybe the 50 newton meter. So we have to meet the characteristic of the engine as well as the motor with respect to load condition. Third one, to allow the efficient energy use across the different speed and loads. Okay, so we have to use the fully mechanical energy. So we can say we have to use the 100% mechanical energy to transmit the power to the wheel. But 100% that is not possible, but we can try. So we can transmit the 100% efficiency from battery, otherwise from motor to the from motor, otherwise from engine to the wheels. Okay. So gear function by changing the ratio of the input speed may be the from engine, otherwise from the motor, to the output speed of the wheel. Okay, so this is the gear function, so we have to change the speed, correct? So by changing the speed and by changing the gear we can change the speed. So this is the known as a gear ratio. So what is a gear ratio? So gear ratio is nothing but input speed upon the output speed. So there is a ratio of the input speed to the output speed. That is your gear ratio. In the case of the torque, we can say the output torque upon the input torque. So you can speed and torque both are the inversely proportional. Correct? So we can say in the first gear system, we will get like less speed but high torque. Correct? So normally, suppose you are driving the four-wheeler, so we always operate our vehicle in the first gear. So in the first gear, so we can say the first gear system, low speed and high torque. In the case of the second gear system, otherwise we can say the third gear system, high speed and low torque. So slowly you will increase the gear. So maybe the initially first gear, then second, then third, fourth, and fifth. Correct. So normally in the every vehicle have a five gear and one is the reverse gear. Correct. So first gear there is an initial condition, then slowly increase the speed, then second gear, then third gear, fourth gear, and fifth gear. So normally in the on the highway we can drive on the fourth and fifth gear system, correct? So we can say gear ratio that is inversely proportional to the speed. So you can say the gear ratio for the speed case, it is a ratio of the input speed to the output speed. But in the case of the torque, you can say the output torque to the input torque. Okay. So if you have any query, then please let me know in the slide number 5. Is there any query? Okay. So benefits of the gear system. So in the ICE vehicle, maintain the engine with the optimal RPM range. So RPM, that is a rotation per minute. So by using the gear, we can maintain the optimal RPM range. Second one, provides the different torque level for the different condition. So we can get the different torque level, correct? But in the case of the EV, simplify the drivetrain with fewer gear, often the one speed. So normally in the 99% case, we can use only single transmission gear system. Okay, that's why here I written the single speed. Okay. Second point, then still improve the efficiency and performance when used properly. So suppose we have a single transmission gear system, so we can improve the efficiency, we can utilize the maximum energy by running our vehicle on the optimize the speed as well as to optimize the load. Okay. So internal combustion engine operate efficiently within the narrow RPM range. So that is typically the 1000 to 6000 RPM. Okay. Gear are essential match engine the speed to require the wheel speed. Okay, so by using the gear, we can make the speed, so we can operate the engine effectively. Starting from rest, climbing hill, and cruising is highway speed. So suppose you want to drive at a constant speed, then we can say it is a cruising at highway speed. Okay, how it work? So multi-speed gearbox, manual or automatic. So nowadays in the market we have two type of vehicles. So there is a manual gear system and automatic gear system. Okay, in the manual we have to change the manual gear. Correct. So suppose your speed is a 0 to 10, then we can set the first gear. Then 11 to 20, then we can say second gear. Then 20 to 30, we can say third gear. 31 to 40, fourth gear, and above 40 we can say fifth gear. So normally we can say all vehicle have a five gear system, correct? So maybe the some vehicle have a six gear system and one more gear, that is a reverse gear, correct? So suppose you want to drive your vehicle reverse, otherwise back, correct? So there is a manual as well as the automatically. Manually you have to press the clutch and then you have to change the gear, correct? But it automatic, it is automatic changing the gear. So suppose your vehicle is running on the 0 to 10, then your gear is automatically first gear, correct? So that is a, while design the vehicle, that is automatically coded. So your speed is maybe the 10 rpm, 10 kilometer per hour, then my gear is a first gear. Okay, lower gear provide the higher torque for acceleration and the climbing. In the previous slide I already told you, in the first gear low speed and high torque, correct? So lower gears provide the higher torque and acceleration and climbing. Higher gear reduce the engine speed for the fuel efficiency during the cruising. Okay. Component involve clutch, so there is a manual transmission, torque converter, there is automatic transmission system, gearbox with 4 to 8 forward gears. So minimum that is a 5 and maybe the 8, but till now I seen total 6 gear, but maybe some vehicle have a 8 gear. Differential to the distribute the power to the wheel. So we have to distribute the power to the wheel so we can drive our vehicle. Challenging, frequently shifting in the manually transmission system, so we have to frequently change the gear, maybe the within a 10 second, maybe the 20 second, maybe the sometime, maybe the 1 minutes, correct? So frequently we have to change the gear system, so that time maybe the wear and tearing effects, correct? So there is a losses and we have to regularly maintain the regularly service, correct? So we have to do the regular service. Engine losses due to the friction and complex mechanism, correct? So I hope you all of you seen the gear, so how gear looks like, correct? So while changing the gear, so friction will happen and maybe sometime after we have to go for the like service center to repair the gear, correct? Higher maintenance. Okay, so this one is another challenges for the gear system. Why EV needs the few gear system? As I said in the beginning of the class, mostly 99% case EV use the gear, but there is a single speed gear. Electric motor deliver the maximum torque from the 0 rpm and maintain it over the broad speed range. So there is a main benefits of the EV. So there is a maximum torque we can get from the 0 rpm. They can operate from the 0 to 1400 plus rpm. So multiple gear are often unnecessary. So you can see in the case of the motor, we can operate the motor by maximum range, correct? But that case is not possible in the IC engine. That's why IC engine is required the gear system. Typically, gear setup, single speed reduction gearbox is most common in the EV. So example is Tesla Model 3, Nissan. But you can see the most of the vehicle, there is a 98 to 99% vehicle use the single speed reduction gearbox. Okay. The gear ratio reduce the high speed motor output to usable the wheel torque. Okay. So ultimately we can use the gearbox to reduce the speed and torque. So we can optimize the use of our engine as well as we can use the motor. Okay. Special case multi-speed gear system. Yes, as I said, into some vehicle, maybe the multi-gear system, but there is only 1 to 2% chance. High performance EV use the two-speed gearbox for better low-speed acceleration, higher top end efficiency. Example, Pros Taycan, that is a two-speed real axial gear system they use. Okay. Electric commercial vehicle may use the multi-speed transmission to handle heavy load, steep gradients. So suppose is there any steep gradients, then we can use also multi-speed gear system and towing. Correct. So maybe the road is not smooth, then we can use also multi-gear system. Okay. So comparison, we can say the number of gear. So comparison between the ICE vehicle and EV. So number of gear in the ICE vehicle there is a 4 to 8, but in the EV usually one gear system. Correct. Torque curve narrow, need to gear shift. Torque curve in the EV flat and broad. One gear is enough. Okay. Clutch required, yes, in the case of the manual, but clutch required in the EV, no. Maintenance high, more part and oil because there is a more friction. But in the case of the EV, there is a low maintenance. While discuss the first class, why we are shifting from ICE vehicle to the EV, correct? Control complexity high, especially in the manual. Low, automatic control by the vehicle control unit. So VCU stand on the vehicle control unit, correct? So that's why we can say the AV is better than the ICE vehicle. So while EV battery operated vehicle often use the single transmission system, so this slide we already discussed, but in the form of the theory form, we can say torque speed optimization. Electric motor have higher torque at low speed, but limited to the peak RPM. Gear ratio allowed the motors to the run at the optimum RPM for the efficiency and deliver the sufficient torque at wheels. So, in summary form, we can say why we have to use the gear, because we have to optimize the speed with respect to the engine, otherwise with respect to the our motor. Correct. So we can get the maximum efficiency from the mechanical power as well as the electrical power. Okay. Improve the acceleration. So gearing can multiply the torque at the wheel during the initial acceleration, which is especially helpful for the heavy wheel vehicle climbing incline and towing road. Higher top speed without the gears, top speed would be the limited by the motor's maximum speed. That is the one reason. Second one, the reduction the gears allow the higher vehicle speed without the forcing the motor to spin beyond the safe limit. Correct. So that's why we are using the gear system in the both vehicle. Reduce the motor size and cost. There is an again advantage we can say. Gear allowed to use the smaller, lighter and cheaper motor. So suppose we have a gear system, then we can reduce the size of the motor, we can reduce the weight of the motor. Motor can operate within the narrow speed range, reduce the motor wear and thermal load. Energy efficient, operating the motor near the most efficient RPM. So we can say the 100% efficient, but again I can say 100% efficient, it is not possible. Extend the driving range, reduce the energy consumption, and improve the regenerative braking efficiency. Okay. So regenerative braking efficiency, how we can generate the regenerative braking. So that we will see in the maybe the third unit and as well as in the MATLAB simulation file. Okay. Yes, multi single speed versus the multi speed. Most battery operated electric vehicle use the single speed reduction gear for the simplicity. Some performance of the EV, example the Prost Taycan, use the two speed transmission for better low speed acceleration and more efficient high speed cruising system. So benefits, so we can say the reason and benefits. So torque multiplication, better acceleration, motor speed optimization, benefits, so efficiency and the range, top speed management, allow the high vehicle speed, motor size reduction, low cost, weight and heat, simpler drivetrain, so fewer moving parts and higher reliability. Because of the fewer moving parts, so we can say the less friction, and then we can say it is a higher reliability. Type of the gear in this electric vehicles, so we can say the single speed reduction gearbox. Most of the time we can use the single speed. So majority of the EV use the single speed gear ratio, simplify the drivetrain, no manual shifting required. So in which vehicle single speed reduction gear system use? So Tesla's 3, Nissan Leaf, Hyundai, and Tata Nexon. So many more company use the single speed reduction gearbox. But here I mention only few. Multi-speed transmission system. So we can say the some high performance EV use the two-speed gearbox system for the low speed torque and high speed efficiency. Okay. So there is a pros Trican as well as the Rimpec Nevra use the two-speed gearbox system. Commercial and EV truck. So heavy duty. So you can say the truck that is a heavy duty. So maybe the bus, delivery truck may use the multi-speed automatic and automatic manual transmission system. Used in the Volvo, BYD, Ashok Leyland electric commercial vehicles. Correct. So in the used car, that is a multi-speed automatic, otherwise automatic manual transmission system. Yes. Till now, any confusion? So there is a gear system. There is an introduction of the gear system. Any confusion? Any query? Now we move ahead with the mechanical modeling.
Sir, one question.
Mm-hmm.
Sir, in my EV, there are three gears, sir. One, two, three speed. Uh, is there gearbox or in motor control there, sir? Motor control, matlab, means matlab, different point in the motor winding to speed control.
Yeah, so we can use the multi-phase motor to operate the multi-gear system. So normally we use the three-phase PMS and BLDC motor, correct? But in the multi-speed gearbox, we can use the multi-phase motor. So we can control the multi-phase similar. So ultimately, we have to control the voltage and current, correct? Understood? You know,
Yes, sir. Understood.
correct. So your question was, so how we can control the motor in the case of the multi-gear, correct?
Yeah, yeah, yeah. Motor control.
Yeah.
Uh,
So
mm,
we have to work on the motor controller part. So suppose you are drive on the your vehicle, maybe the second gear or third gear, correct? So we have to operate the motor into like single phase, two phase, three phase, four phase, or five phase. So that is a depend on our control algorithm, and that we can see in the third chapter. That is, I think, third chapter, yeah, second chapter to control of the EV. Okay, any other question? Any more question from the other student? Okay. So mathematical modeling of battery electric vehicle, most important part. So we have to model the mathematical modeling of the EV, correct? So mathematical model of the battery operated
Sir,
electric vehicle. Yes. Any confusion? Any query?
sir, is this the topic of chapter 2, mathematical model?
So your noise is not clear. Can you repeat?
So mathematical modeling is part of chapter 2 or chapter 1?
I think chapter one, I am not sure, but suppose it is a chapter two, then we can count in the chapter two. But as of now, I don't know. So maybe the chapter two, yeah, maybe the chapter one. I am not sure.
Yeah, the PDF file shows that it is in chapter 2. So I think chapter 1 is finished, so yes.
Yeah, so chapter one, maybe the finish. Yes, so suppose this mathematical modeling of the battery, it is written in the chapter two, then this one is a chapter two part, correct?
Okay, sir.
Because I got comments from the Jitendra sir, so as per the institute norms, we have to modify the syllabus. So maybe then I modify the syllabus and I kept this mathematical modeling in the chapter U2. Okay. So maybe that is a part of the chapter 2, but it does not matter. So it is a part of the syllabus. Okay. Okay. So maybe this is a chapter 2, but again, I can say it does not matter because it is a part of the syllabus. Okay. So mathematical modeling of the battery operated electric vehicle is essential for the understanding their performance, efficiency, energy consumption, and control strategy. Correct. So why we have to do the mathematical modeling? So we have to see the performance of the vehicle, efficiency of the vehicle, energy consumption, control strategy, and everything. This involve in the representation the various components and dynamics of the vehicle using the mathematical equations. Correct. So vehicle longitudinal dynamic model, electric motor model. So in the first semester, I already taught you there is a analysis of the electric motors, correct? So ABC to DQ conversion and to vector control, scalar control, many control algorithm also we studied in the first semester. There is an electric motor model, battery model. So we have a different type of battery: lithium ion, lead acid, nickel cadmium, correct? So as well as the super capacitor, solid state battery. So we have a bit different type of batteries. So which battery we have to use for the particular vehicle, correct? So we have to also analysis the battery model, drivetrain, and the transmission model. So we have to also see the drivetrain. So how you can transfer the electrical power to the mechanical power and ultimately mechanical power to the wheels, correct? So how we can transmit this power, energy consumption model. So in the last class, we see transfer the energy from the battery to the transmission shaft to the wheel. So how we can transfer the power, correct? So that is a energy consumption. And last one, that is the overall control system models, correct? So we have to see these six components while we design the mathematical model for the electric vehicle. Any components you are thinking that is a missing in this slide? So from my knowledge, I think we covered all the components. There is a major components. So first one is a longitudinal dynamic model. Yes, electric motor. Which type of motor you are using? BLDC, PMSM, induction. Battery model. So which type of battery you are using? Drivetrain transmission model. How you transmit the power, energy consumption, yes, and control system. So I think from my knowledge, we have a total six models. So we have to work. Correct. So first model, we can say the vehicle longitudinal dynamic model. So most important part, so vehicle longitudinal dynamic model. So we have to ultimately calculate the force. So there is a traction force. In the previous class, we already seen the what is a traction force, correct? So again, because this is the mathematical modeling, so we can say the traction force. Traction force is nothing but combination of total four force. First one, that is a rolling force, aerodynamic force, gradient force, and fourth one, that is a inertia force, correct? So in the previous class we already discussed the first, second, and third force, and fourth one, that is a inertia force. So that is nothing but overall inertia of the vehicle. Otherwise you can say the speed into mass. Okay, so what is a rolling force? Rolling force is nothing but mg into cr, where m is a mass, g is a gravitation, and cr is a low rolling coefficient. Okay, aerodynamic force 1 by 2 into rho into area into cd, that is a coefficient, into velocity square. Gradient force mg sine theta, that is your gradient force. And inertia, that is a m mass into dv by dt, that is a velocity. So where we can say m is a vehicle mass, that is a unit is a kilogram, g is a gravity, meter per second square, cr is the roaring register coefficient, that is a unitless, rho there is a air density, kilogram upon the meter cube, there is a air density, a there is a frontal area, meter square, Ct there is a drag coefficient, V there is a velocity meter per second, and theta there is a road slope, correct? So there is a radian. So this one is the first equation, and we can say vehicle longitudinal dynamic model. So we have to make, and based on this friction force, we can calculate all the force. Otherwise, we can say, suppose we know all these four type of force, then we can calculate the traction force. Okay. Second one, there is a electrical model. Okay. So electrical model, we can say simple DC motor. There is a fundamental motor, and then based on this DC motor, we can derive the induction motor, PMS, BLDC motor, and etc. etc. Correct. So usually modeled using the equivalent DC motor or detail the PMSM and PMSM and induction motor. Correct. So simple DC motor equation, we can say V equal to E plus IR, where E there is a back EMF, V there is a voltage, E there is a back EMF, I there is a input current, R there is a resistor of the stator winding. Okay. That back EMF we can define the Ke upon omega. Omega there is a speed in radian per second, and K that is your constant back EMF constant, motor EMF constant, that is a unit is a voltage second upon radian. Same we can write the torque is equal to Kt into I, where Kt that is a electromagnetic torque constant, and I that is a current. How much current is flow from the flow through the our what we can say the stator winding, correct? Maybe the three-phase stator winding, maybe the six-phase stator winding. So this equation 1, 2, 3, that is a fundamental equation, and based on this fundamental equation, we can derive for the flux, torque, and every parameter, correct? Whatever you want. Most important part, students. So unit is the most important. So voltage, there is a volt, current, there is ampere, resistor, ohm, back EMF voltage. Most of the time a student is forget to return the unit for the back EMF constant as well as the torque, correct? So unit for the back EMF constant, voltage into second divided by the radian. So there is a voltage into second divided by the radian, and motor constant, there is a torque constant, motor torque constant, Newton meter upon ampere. Third one, there is a mathematical model for the battery. Okay. So we can say the Thenwin model. We already know the Thenwin. So Thenwin model is nothing but we can say the equivalent Thenwin VTH RTH and RL. So this is the Thenwin equivalent circuit. So we can say the Thenwin equivalent circuit. And we have to find out the current. So there is a IL and there is a load current. So how much load current? So IL equal to simple Ohm's law. There is a VTH divided by RTH plus RL. Because RL and RTH both are connected in series, correct? So we can say IL equal to VTH divided by RTH plus RL. So as per the Thenwin model, we can say battery voltage equal to open circuit voltage minus I into R internal resistor minus VRC. VRC is nothing but voltage across the resistor and capacitor. So that is the first equation. There is a battery voltage. How much battery voltage? So there is an open circuit voltage minus IR integral resistor. There is an internal resistor minus VRC. And what about the SOC? That is a state of charge. So SOC initial time T naught minus 1 upon Q, where Q there is your reactive power divide by T naught, sorry, not divide by, that is your integration T naught to the T I battery T. Okay, so there is a SOC. So where B battery, there is a battery voltage, VOC, there is open circuit voltage, R internal register, and VRC voltage across the RL RC branch. That is a transient behavior. Correct. So this model for the battery, correct? So you have to design the battery also.
So Q is reactive power or charge?
Sorry, so Q is a charge, not the reactive power. So Q is a charge. Q is electric charge, not the reactive power. Okay. Yeah. So yes, Q is a charge, not the reactive power. So based on the Thenwin model, we can make the battery model. Okay. Yes. If you have any confusion, then please let me know. Okay. And if I
Sir,
made
how
any
to
mistake,
calculate, sir, how to calculate I battery?
yes, I bet I remember your question. You asked me in the second question. So we will discuss in the next class. So this is the second unit, correct? So I told you we will calculate the current of the battery in the second unit. So we already started the second unit. So you will see how we'll calculate the current of the battery for in the second class, in the next class, tomorrow class.
Sir,
Is it
could you
okay?
go back slide, please, sir?
Yes.
One slide again, back. Uh, in case of force due to rolling resistance, isn't it mgcr cos theta?
I
I think you
think
told us in lecture
uh,
one.
mg mgcr cos theta. That is
Yes, sir.
cos mgcr cos theta. Just 1 minute. Cos mg cos theta.
In lecture two,
So I return in the mg cr cos theta.
rolling resistance force, downward
Good graph.
force.
Mg cr cos theta. So you are saying so cos theta is missing term?
Yes, sir.
Yeah, maybe.
Theta is for slope, sir. If
So
the road is
theta is slope. I remember. So
Yes, sir.
theta is suppose this is the road condition and we have a this slope and we have this
Sin theta is
vehicle.
the horizontal part and cos theta is the vertical part.
Yeah.
Rolling
So
part.
this is the theta. Then we can say this is the your cos theta and this is your maybe the sine theta. I remember this thing, but I am confused about this cos theta is include or not. So I written in the last slide cos
Yes, sir.
theta.
You have written in
Yeah,
lecture
so
first.
maybe that is a cos theta. So I will change here. I will change while I send this lecture notes. So mg cr cos theta, correct? And there is a gradient force is a mg cos theta, correct? Mg sin theta.
Yes, sir. Yes,
So gradient force is correct. Yeah, still it is
yes, sir.
wrong.
Yes, sir. It is
It is
correct.
correct. Okay. So I will change while I send this lecture notes. So rolling force, that is a mg cr cos theta. Okay. Just 1 minute. I will confirm also. Just 1 minute. Yes, that is mg cos theta. Yes, correct. So I will change this one. Okay. Yes. Any more confusion? Any more query? Okay. Yeah. Next one, there is a drivetrain and transmission model. So assuming the single speed transmission system, so normally we can see in the 98, otherwise you can say 95% vehicle use the single speed transmission system. So torque, so vehicle torque is equal to eta into gear. So eta gear is nothing but gear efficiency into torque motor into the I divided by R. So what is the I? I is nothing but gear ratio. So maybe the 2 to 3 gear ratio, maybe 3 to 5, maybe the 5 to 6. So what is a gear ratio? Correct. So that is your I. Eta gear. So there is a gear efficiency. So what is a gear efficiency? Maybe the 90%, maybe the 95%. So what is a gear efficiency? Correct. T motor, so there is a torque motor. Okay, so how much torque is there on the motor wheel? Correct. So that is your motor torque, and here is a wheel torque. So suppose motor torque is maybe the 5, maybe the torque motor is equal to 5 Newton into meter. So maybe the wheel torque, maybe the 4.5. Yeah, there is a depend on the gear ratio, correct? Maybe the 4.5, maybe the 5.5, maybe the 6. So that wheel torque is actually depend on the gear efficiency, depend on the gear ratio, correct? So we can say the N gear, there is a gear efficiency, I, there is a gear ratio, and R, there is a wheel radius, and that is a in the meter, correct? So omega motor, so omega is a motor speed is equal to I into omega wheel, correct? So what is a motor speed, correct? So there is a I into the omega wheel. So we can say how much speed, what is the speed of the your wheel, correct? So there is your omega. So omega is nothing but radian per second, correct? Not the Newton RPM. So suppose you want to change the RPM, then you can multiply 2 pi n by 60, correct? Okay. So yes, any confusion in this slide? So equation number 1 and 2. So that is the most important. So suppose you have a gear system, then what about the wheel torque, correct? Not the motor torque, but wheel torque. Okay.
Sir,
Sir, how can
Yes, go
Sir.
ahead.
sir, if the gear ratio is 2:3, then is it 2 is across motor side or transmission side?
2 is the motor side and 3 is the transmission side. So we can say this is the motor and this is the wheel. Correct? Yes.
sir,
Yes.
sir, how can we measure torque in motor, sir?
So torque sensor is there. So we have a torque sensor also. We can use the many sensors to measure the many parameters. So speed, we can use the encoder to measure the speed of the motor. We can use the torque sensor. We can use the flux sensor. So if you want a list of the sensor which you use in the EV, then I will make the one slide. So which type of sensor we are using in the EV to measure the different parameter.
Position sensor, just speed sensor is Hall effect sensor.
So Hall effect sensor and the speed sensor both are the different. So position sensor is only see the position of the rotor. In the BLDC motor, how we can operate the BLDC motor in the first semester I already discussed, I think so. So we have to sense the rotor position, correct? So we can say suppose this is the rotor, correct? So suppose this is your rotor. Suppose this is your rotor, correct? So maybe the Hall effect sensor one here, second here, and third here. So normally Hall effect sensor there is a 120 degree, 120 degree aligned to the each other, correct? So we have to sense the rotor position. So maybe this is the north pole and this is a south pole. So where is the north pole? So that is a near to the Hall effect sensor 1, yeah, near to the Hall effect sensor 2. So based on this rotor position, we can rotate our rotor, correct? So we can say we have a switch, electronics commutator. If you remember that electronics commutator, we have all electronics commutator, correct? So we can say we have a 6 switch, and based on this switch, we can operate the BLDC motor. Okay. So Hall effect sensor is nothing but we have to see the position of the rotor. Based on the rotor position, we can operate the inverter part. So this is a commutator part, correct? And by the encoder, we can measure the speed. So we have to use the encoder, proximity sensors. So many type of encoders are there in the market. So depend on the your accuracy, depend on the your cost. We have to use the also proximity sensor, resolver, proximity resolver. So many type of sensors are there to measure the speed. But by Hall effect sensor, we cannot directly measure the speed, correct? So once you measure the rotor position, then you can operate the BLDC motor. Yes, so we have to use the many sensor to measure the many parameters. So no issue. So I will make the one more slide for the maybe the next class if I will get the time to which type of sensor we have to use for the which parameter. Correct? Maybe the torque, speed, current, voltage, charge, temperature, vibration, noise. So many sensor we are using. Yes, good question, good discussion. Today I am happy you are asking something. Yes, any more confusion, any more question? So if you are asking the many question, then I am happy. So you are listening the lecture and you are active. Yes, any more question? Okay. So energy consumption. So energy drawn from the battery. So E total is equal to integration starting to the maximum time period into the P into T. So that is a power into dt. So is equal to 0 to T. There is integration. Power is nothing but product of the voltage and current. So final equation we can say the E total equal to integration. There is a total area cover under the maybe this is your curve. Maybe this is your time period. This is your time period. So how we can calculate the area? So initial time to the maximum time, correct? So based on this, we can calculate the total energy, correct? So this help calculate the range and efficiency. Okay, so there is a energy. Control system, there is a last module. Speed controllers, so PID controllers. So there is a normal controller already first semester you implemented in the induction motor as well as the like simple PID controller. Torque demand and the traction control, okay, and as well as the your battery management system for the SOC, SOH estimation. So battery management system, there is a large, not we can say large, but it is a wide area. So maybe you can choose the BMS for your project, correct? So depend on your interest. Okay, yeah, maybe you can choose drive system, how you can controlling the your vehicle. Correct. So many research topics are there. So based on your interest, you can choose the research project for your current semester as well as your next semester for your thesis. Okay. Yes. Till now, any confusion, any query? Any confusion, any query for the mathematical modeling? Still, mathematical modeling is not completed, correct? So this is just starting. Any confusion, any query? Okay. So now first example. So electric scooter has a mass 100 kilogram. So mass is 100 kilogram and is moving on the flat road. So road condition is a flat, is constant speed 36 kilometer per hour. The rolling register coefficient is 0.015. Air drag is negligible, so we can neglect the air drag. Calculate the traction force. So what is a traction force? So we have to calculate the traction force. Okay. So we can say the given data, so 100 kilogram mass is a given, that is 100 kilogram. Speed is given, that is a 36 kilometer per hour. So velocity is given 36 kilometer per hour, but we have to convert into meter per second, correct? So 36 kilometer per hour. So kilometer, there is a 10 raised to power 3, and hours, that is a second. 1 hours equal to 3600 second, correct? So we can convert 36 kilometer per hour to the meter per second. So it is around like 10 meter per second, correct? So 1 hour is equal to 3600 second, and here is a 36,000, correct? So there is a 10 meter per second, and rolling register coefficient is given, that is a 0.015. Air drag we can neglect, so calculate the traction force. So we have to calculate the traction force. So what is the formula of the traction force? So we've seen the formula of the traction force. So there is a railing register, aerodynamics, gradient, and inertia. Okay, so we can say the force, that is your rolling, plus force, that is your gradient, plus force, that is your gradient force, rolling force, and one is a inertia and other one is a aerodynamic. And last one, that is your inertia force. So for this example, inertia is not given, so no need to consider for this force. Aerodynamic force, air drag is negligible, so we can also neglect this one, because in the question air drag is negligible, so we can neglect this one. Gradient force, no need to consider for this example because parameter is not given. So we have to calculate that there is a rolling register also. Only rolling register, correct? So F traction is equal to F rolling. So formula for the F rolling. So mgcr into cos theta. So cos theta is missing in this question. So we can assume cos theta equal to maybe the 0.5, maybe the 0.6 degree. Correct? So we can assume cos theta is equal to 0.6 degree. Correct? So what is the final answer? So now you can calculate the AMG. So G is a missing, but G is a gravitational. So G is a 9.8 meter per second. Meter per second square, correct? So that is a gravitation of the earth. CR is a given. Yes.
So the question says that it is a flat road. I think theta must be 0 degree.
Just 1 meter. Yeah, question is written flat load, correct? Yes, you are correct. So no need to assume the cos theta value. So cos theta we can say the 0 degree. Yes, in the question it is a written it is a flat load, correct? Flat flat rod, so no need to give the theta. So we can say the cos theta equal to 0 degree.
Cos
So
theta equals
theta,
to
not
0.
not cos theta, theta equal to 0
Theta
degree.
is 0, cos theta
Yes,
equals to 1.
yes. 1 meter. So simply I can write so theta equal to 0 degree. So cos 0 degree is equal to cos 0 is equal to 1, correct? So that is a 1, and G is equal to gravitation, that is a 9.8 meter per second square. So what is your final answer? M is given, that is 100 kilogram. G, that is your gravitation, that is a 9.8. And CR, that is your rolling coefficient, 0.015, and cos theta is equal to 1. So what is your final answer?
14.715.
Yeah, as per my calculation, if rolling equal to 14.17, sorry,
715.
sorry,
Sir,
14.71. Yes, so as per the my calculation, I got,
but then what is the meaning of velocity here? Not used here.
sorry,
Velocity is not used in formula, sir. Then
no
what is
issue, no issue. So, but that is a like speed, correct? So, application is a scooter. So, weight is 100 kilogram, and moving on the flat road at the constant speed is a 36 kilometer per hour. So there is a no use, so no need to convert. So suppose you don't want to convert, here I convert because that standard unit is a meter per second, correct? So that's why here I converted. And how we can convert? So 1 hour, that is a 3600 second. So suppose you don't want to convert, then no need, because in the formula there is a velocity is not required. Yes, any confusion for this numerical?
sir? Rolling force in Newton meter or Newton only? It is this torque.
Rolling force, Newton meter, there is a torque, correct? So Newton only. I think force unit is a only Newton, correct? Not the Newton, only Newton. Yes, I written for the torque. Torque is a Newton meter. Force is only Newton. Yes. So force is a Newton, not the Newton meter. Correct. Yes. Any confusion for this numerical? Simple numerical. Any confusion? Then we move ahead with the second numerical. Any confusion for this numerical?
No, sir.
Okay. Example number 2. Uh, BEV, there is a battery operated electric vehicle with mass, there is 150 kilogram, is accelerating at 1.5 meter per second square. A rolling register coefficient, there is a 0.01. Air drugs is negligible. Road is a flat. Wheel radius 0.3 meter. Gear ratio, there is a 5. Gear efficiency, there is a 90%. Calculate the total traction force. We have to calculate the total traction force, wheel torque, motor torque, and motor speed at 36 kilometer per hour. So we have to calculate this parameter. Yes. How we can calculate the traction force? So first parameter, first one, total traction force. Any idea how we can calculate the traction force?
Just MGCR, sir. Just the rolling.
MGCR cos theta is equal to 0, correct? Cos theta. So suppose I can write the formula, but cos theta is equal to 1, correct?
Yes, sir.
So AM is how much M?
150.
150 G.
9.81.
9.81. CR how much? There is a 0.01. 0.01 into 1. So cos theta is 1. So how much? 150 into 9.8 into
14.7.
how much?
14.7.
Just let me check. 150 into 9.81 into 0.01. 150 into 9.81 into 0.1. Just a minute. 150 into yes, 14.71. All of you got the same answer?
Yes, sir.
Yeah. So this one is a traction force. Second parameter we have to calculate the wheel torque. So second one is a wheel torque. How we can calculate the wheel torque?
So, sir, what about mass into acceleration? Inertia force, acceleration force.
Sorry.
Mass into acceleration.
Oh, acceleration is given.
Right.
Acceleration is given, correct?
Yes, sir.
Okay. Yeah. So just 1 minute. So we
You
can
add
extend.
an MA.
Yeah, we can add just 1 minute. So F traction is equal to m into a. So m is a mass, a is a acceleration into your force rolling resistor, correct? So am there is a 150. A is how much? 1.5 plus F rolling.
F rolling is 14.7.
Yeah, so here I changed the terminology. So this is the F rolling. F rolling. F. Yeah. So F rolling, we got the mgcr cos theta. So we got the F rolling is equal to 14.71 Newton, correct? And we have to calculate the final F traction. So I missed, there is acceleration is given. So acceleration is given, correct? So we have to add the acceleration. So there is a mass into acceleration plus F rolling. So mass is given 150 and acceleration is given the 1.5 meter per second square. And rolling force we already calculate that is a 14.7. So how much now? So that is around like 239.
Yes, sir.
150 into 1.5 plus 14.7. 242.
290, 220, 239, sir.
Just 1 minute. So
239.71.
150 into 1.5 225 plus 14
Christian
points.
Palestine, sir.
239.7, correct?
Yes, sir.
239.7, there is a Newton. Yes, this one is your final answer. Correct? Yeah, so there is a total traction force. So first we have to calculate the rolling, otherwise you directly add the like mass into acceleration because acceleration is given in this numerical. Yes? Yeah, any confusion? Any query? Yes. Now second part is a wheel torque. So any student remember the formula of the wheel torque? So what is the formula of the wheel torque? Wheel torque is equal to your force. So total force. So there is a force, traction force into your radius,
Wheel radius, sir.
wheel radius. So fraction torque, we got 239,
0.71.
239.71. And what about the radius? How much radius?
0.3.
0.3 meter. Correct? So no need to convert into millimeter, correct? So there is a meter, is a standard unit, 0.3. So how much?
71.91.
239.71 into 0.3. 71.91. What is a unit?
Newton meter.
Newton meter. Yes, if any student have any query, then please let me know. Huh? So wheel torque is equal to F traction into radius, correct? So F traction into radius, that is your wheel torque. Yes, third parameter, motor torque. How we can calculate the motor torque?
From efficiency and gear ratio.
Yes, correct. So motor torque equal to wheel torque divided by into. So this formula,
No, sir.
what is the formula?
Eta into T I by R.
Okay. T motor I upon R. This one, correct? So what about the gear efficiency? How much gear efficiency? 90%. So that is your 0.9. So 90%, that is a 0.9%, 0.9 gear efficiency. Motor torque, so this one is motor torque, yeah, what? So torque motor we have to calculate, correct? So original formula is
In left side there is T torque of wheel, sir.
torque of wheel. So this one is a wheel, and we have to calculate the motor torque. So torque of wheel we got 7.91. T motor we have to calculate. I, what is I? I is given
5, sir.
gear ratio, there is a 5, yes. 5. And R radius how much? 0.3. Yeah, so how much? Yes, student, how much? So torque motor is equal to 15.98. Yeah.
4.79 Newton meter, sir.
4 point.
79.
Please check the another student. So 21.
4.794.
Point 4 point.
794.
Okay. So I got the 4.78. So there is a nearby 4.79, yeah, 4.794. Okay. So there is a torque Newton.
Sir, sir,
Newton
why torque of motor is less than torque of wheel?
torque of.
Torque of wheel. I think the motor torque must be larger than the torque of wheel.
Yes, so maybe the losses, yeah, I don't know. But obviously, yes, wheel torque is a motor course is more compared to the wheel torque. But what about the gear ratio? Gear ratio is a 5.
Yes, sir. As the gear increases, torque decreases, sir.
या सेम थिंग ये गियर घटाउने खाली रहेछ यसले स्पिड घटाइ
I don't know, but as per the formula, so there is a torque wheel, there is a 71.91, and motor torque, there is a 4.79, and gear ratio is a 5. Gear ratio is a 5, so your speed is a high. Yeah, maybe because of that is a gear ratio. That's why. Because gear is a high, correct? So fifth gear. I think so. That's why. But I am not sure. But most probability because of the gear, so there is a high gear ratio. So your speed is a high and torque is low. But I have to check. But as of now, based on this formula, so we got the torque. So there is a wheel torque, there is a 71.91, and motor torque, there is a 4.79. Correct? Yeah. And last one, that is your what motor speed. So how to calculate the motor speed? Yes, first
From
one.
power, I guess.
Mm-hmm. What you said?
From power, maybe, sir.
From power.
P is equal to force into velocity.
Force into velocity. So P equal to force into velocity. So force is how much? So there is a traction force. So there is a 239.7. And what about velocity? What about velocity?
I don't understand that the motor is speed at this
P
the
equals P
same
omega.
speed. 36 kilometer per hour is the speed.
So question they are asking motor speed at 36 kilometer per hour.
So it says it must be RPM of motor. We have to use different formula.
No, so your vehicle is running at 36 kilometer per hours, correct? So during this time, what is your speed of the motor?
The
So it
speed
is,
of motor is measured in RPM, sir.
yes, it is RPM.
Then the formula can be velocity is equal to omega r.
Correct. So velocity V speed is equal to
Omega r.
velocity omega into R.
Yes, sir.
So this omega is equal to radian per second, correct?
Yes, sir. 2 pi n by 60.
2 pi n by 60 into R. So this is your speed.
Yes, sir.
Okay. Otherwise, I can write omega will. Sorry.
This is the omega of wheel. Then using gear ratio, we can calculate speed of motor.
Velocity upon the radius.
Yes, sir.
So what is a velocity?
36 kilometer per hour.
Yeah. So
It must be 10
yeah. So we have to convert into the
meter per second.
meters per second. So V, that is your how much? 10. And radius
0.3.
0.3. So how much? That is a 10 by 3. So that is around 30
No, so you have to you also have to multiply. Yes, sorry, it is correct.
Yeah. No need to multiply.
30.33 radian per second.
Correct. So final formula, there is a will omega will velocity divided by r. So velocity is 10. How we can calculate velocity? So that is a given the speed, there is a 36 kilometer per hour. Correct. So speed is a 36 kilometer per hour. So we have to convert into the velocity. So in 1 hour 3600 second. So then we can get the v equal to 10 meter per second square.
No, sir, meter per second.
Sorry,
only.
yes, meter per second. Correct? Yeah. Any confusion for this numerical?
So what about the radian per second of motor? We have to use gear ratio.
What about?
The speed of motor. The question asked for the speed of motor, but
Yeah, so you can convert, then you can convert. No?
it must be multiplied by 5.
Multiply by
5.
5. Why
I.
5?
I. Because this is the speed of wheel, so motor must rotate larger because it has less torque.
Gear ratio, sir, because of.
Yeah,
Because
because
of
of the
gear ratio.
gears. Yes. So I was
This
expect
is the
so.
RPM of wheel only.
Yes. So omega will.
No, so omega motor. Omega
So
motor.
we have
is
to
equal
convert into the RPM, correct?
Yes,
So
sir.
omega will. So what is the RPM? RPM. So RPM is equal to what? Omega will
into 60 by 2 pi.
into 60 by 2 pi. Otherwise, in with respect to I, what we can say?
Into I.
Into
Omega
I,
V.
into I we can directly write into I, correct? So 33.33 into 5. I is a 5, correct? So that is your RPM.
No, sir, this is also in radian per second.
Just 1 minute. So radian per second, so we have to convert into the RPM, then we can convert into the gear ratio. So first you can convert. Just 1 minute, I have to add one more slide. Yeah. So we got omega will equal to 30.33 radian per second, correct?
Yes, sir.
Now we have to calculate the speed. So what is the formula of the speed now? Yes.
318.27 RPM.
No, formula I'm asking.
43 point omega into 60 by 2 pi.
Omega equals to 2 pi n by into n.
2 pi n by 60, correct? Omega
Yes,
equal
sir.
to 2 pi
2 pi n by 60
n by 60. Now
Hmm.
what is the n?
RPM in RPM. Speed in
So
RPM.
we have to calculate the n, correct?
Yes, sir.
So n equal to
Omega into 60 by 2 pi.
omega into 60 upon 2 pi. And what is omega?
33.
33.33 into 60 divided by 2 pi. Yeah. Now you calculate. What is the value?
318.
How much?
318.27. 319 RPM.
Just 1
So
minute.
now we have to multiply with I, sir.
Yes.
Just 1 minute. I want to check this one. 33.33 into 60 divided by 2 pi. Yes, so that is a 31.8.27. That is RPM. Now we have to multiply the I, correct? Because that is a gear ratio. So n equal to, so final speed we can say
N of motor.
final speed n of motor equal to n into I. So n is 31.8 into 27 and I is 5, correct?
Yes, sir.
I is 5, yes, I is a 5. So how much n motor?
1592.
1592.
1500, sir, not 500. 1500. 1590.
1592.
Just sorry. 1592.
RPM.
So this is your speed, correct? So this is your final answer, correct? Yeah. So what about the students? So you got the answer? Any confusion? Any query? So in this numerical, so we have to calculate the traction force, wheel speed, wheel torque, and motor speed at 3600 at 36 kilometer per hour. So final answer is so first we have to calculate the total traction force, that is mg cos theta, and cos theta is a flat rod. Then friction torque, that is a ma plus rolling force, correct? So that is your final traction force. Wheel torque, traction force into the radius. Motor torque, that is your gear ratio into the torque, motor torque into the uh, gear divided by radius, correct? And motor speed and finally your how much speed of the wheel. How much speed of the motor. Yes. Now any confusion, any query? Yes, student. Now any confusion, any query? Okay. Now third example, maybe you can do in the assignment. So battery electric scooter with the following parameter is accelerating from the rest to the 54 kilometer per hour, otherwise the 50 meter per second in 10 seconds on the flat road, correct? So we have to calculate the total traction force during the acceleration. So what about the total traction force? Wheel torque, motor torque, considering the gear system, motor electrical power input, considering the motor efficiency, and battery current and SOC drop during the 10 second. So you can try in the next class. I will not the next class, so I can give you the time to solve this example, correct? And then I will solve in the class. Okay. So these are the parameters also given, correct? Yeah. So last topic, it will take around 5 minutes. Then I will close the class. So there is an impact of the impact and benefits of the EV on the utility grid. So what is the impact? Correct. So maybe most of you know about the power system, and maybe there's some of the student working in the power grid area, correct? So first one is increase the load demand. So impact on the impact of the EV on the utility grid. So first one is increase the load demand. Why? Because we have to charge the battery. So there is a mass adoption of the EV, increase the electricity demand, especially during the peak charging hours. So we have to charge the battery. Without the smart management, this can overload distribution transformer, cause voltage drop and the reliability issue, and increase the needs for the grid upgrade. Correct. So this one is the impact on the EV. So that is increase the load demand. Okay. And simple relation, because we have to charge the battery. During the charging, it will take too much current. Second one, load profile shift. So maybe your load profile is shift because of the EV vehicle charging. Traditional load curve may shift due to the evening and nighttime charging. Correct. So during the daytime, maybe the not charging, but during the evening time and night time, you are charging your battery. Correct. So your load profile is totally shift. Localized stress clustered of the EV in the neighborhood can cause, because you are charging your vehicle. So maybe the overloading. So transformer is overloading. Phase imbalance in the low voltage networking. Correct. Sag, swell, harmonics. So there is a lot of stress on the localized, correct? Uncontrolled charging issue. So we cannot easily control the power supply, correct? So if any user charge at the same time, it lead to the peak spikes in the demand, correct? So that is not easily we can control. This stress grade the infrastructure and the rise the operational cost. Okay.
Sir,
Yes.
one question, sir.
Yes.
So main charging issue in the EV operated vehicle, I observed that it is insensitive to the phase grounding, sir. Why, sir?
Can you just repeat your question? That is a charging insecure the
Charging electric vehicle operated system is operated to the phase grounding, sir. In case of phase grounding in distribution system, sir, I observed that problem. Why this type of problem?
insecure means, what do you mean of insecure?
Insensitive, sir. The charge
Insensitive.
it means it is not charged, sir.
There is a phase to ground, correct? You are telling to
Phase grounding. in case of phase grounding, any phase that occur in grounding due to many cases, many causes like service. In case of a service cable failure, it may occur the phase grounding issue, sir. So the battery charger is not sensitive, sir, to the
Uh,
to that of power supply, sir.
okay, so as of now, I don't have any idea about this issue. So maybe I will work out and then let you know.
Grounding, sir.
Is it okay?
Phase grounding.
So currently, I don't have any idea about the why it is not sensitive, why it is not we cannot do correct. But I will find out the answer and let you know.
Okay, sir.
So did you check this condition practically? Yeah, you studied somewhere else.
I work in the same field, sir.
Okay, okay.
In NA. So I got this issue many times, and
So suddenly rise the current. Yeah, what happened? So suppose you are charged for this condition. So suddenly
in
you
case of
got like,
in case of phase grounding, I measure the voltage, sir. There is no fluctuating in voltage, but the charger didn't take any current, sir.
and there is a like high voltage charger or low voltage.
In simple, the charging, sir. EV charging
Simple charging. That is a DC
Three
charging.
gun, three-gun system like charger.
There is a DC charging, DC charger.
DC and AC in both cases.
Both case correct. So no issue. So as of now, I don't have any answer for this question. So I will search and then let you know.
Okay, sir.
Okay. And please message me this question so I remember this question correct. Otherwise, maybe I will forget. So please message me after this class. So
okay, sir. I will send you, sir.
Yeah, just you message the keywords correct. So then I remember.
Okay, sir.
So I hope this one is last slide. There is a benefits of the EV. So what type of benefit we will get? So there is a one is a vehicle to grid. So we can easily connect the vehicle to grid capability. EV can act as a mobile energy storage unit. So we can say the with V2G, so vehicle to grid. So we can easily connect our vehicle to the grid. So there is a benefits. So discharge the power back to the grid during the peak hours, provide the frequency regulation, screening reverse, and the grid balancing, support the grid during the outage and emergency condition. Okay, so we can say suppose we have more power in the battery, so we can directly feed to the grid. So that is we can say V2G and G2V technology. So V2G and G2V. Vehicle to grid and grid to vehicle. Grid to vehicle, normally we can charge our vehicle, and grid V2G, whatever we have energy, we can feed to the grid. Okay. Energy support, yes. So there is from the solar, we can say all solar and discharge when needed. Help in the integrated the viable renewable energy and reduce the certainment time period. Demand response integration. So depend on the demand, we can charge our vehicle and we can also feed to the grid. That is a V2G technology. Defer the infrastructure investment. Yes, suppose you want to implement the like charging facilities, so it again that is a defer to infrastructure investment. So smart EV charging can reduce the need for the immediately grid expansion by the smoothing demand and grid service. So frequency regulation, voltage support, black start capability. So this type of benefit we will get. So yes, so key point from today's class: calculate the mechanical power with and without gear, and impacts and benefits of the EV, and numerical of the EV. In the next class, we will see the more detail about the mathematical model of the EV, and also we will discuss the like numerical as well as the whatever you asked the question in the today's class. So thank you so much. If you have any query, then please let me know. So we can discuss. Otherwise, I will work out for this question and then let you know in the next class. Yes. Any question for the today's class? Good. So today I'm happy because you asked many questions. So thank you so much. So we will meet tomorrow class. Okay.